Hello dear friends, welcome my channels. Today's discussions is reasoning, counting tricks of triangle. So friends, how can I solve this problem? First you will see that you have to counting. This is 1. First you will write it in here 1. This is 2. Because numbering these positions, boundary position is 1 and 2. So it is 1 plus 2 equals to 3. 1 plus 2 equals to 3. And second position. second problem, you will see that here I give a partition. This is number 1 partition. So I will write it is 1, it is 2. Then total triangle 1 plus 2. Just multiply. How many partition? Partition is 1. So multiply with 2 equals to 6. And again you will see you will numbering in here 1 plus 2, but in here partition is number of partition is 2. So sorry friends, in here number of partition is 2, 1 and 2. In here number of partition is 1, 2 and 3. So number of partition is 3. So total triangle 1 plus 2 into 3, that is 9. This is number 1 partition, this is 2 partition, this is 3 partition, this is 4. This is 4. This type of problem, how can I solve? First is 1, then it is 1 and this is 1. After that it is 2. So how can I get? I just adding both 1 plus 2, that is 3. So it is 3. After that 3 plus 3 equals to 6. 3 plus 3 equals to 6. This is only 6. After that 6 plus 4, this is 10. So total number is 10 plus 6, 16 plus 3, 19, 19 plus 1, 20. And total number is 20. And you will take in here only mid positions. This is 1 and this is 6. So 6 plus 1, you will just give a gap. This portion and this portion I will not take. So it is plus 7 equals to 27. And after that, now I will go to discuss counting trick triangle. This is 1, this is 2, this is 3, this is 4. So total rectangle is 4 into 2 equals to 8. And after that in here you will, if you see, that is 1, this is 1, 2, 3, 4, 5, 6, 7, 8. So number of rectangle, number of rectangle is 8 into 2 equals to 16. Now friends, we have to find out the number of unit digit in the following expression. So friends, whatever you see, 1 factorial to the power 99, the unit digit of 1 factorial whole to the power 99 is 1. The unit digit of 2 factorial to the power 98 is 4. How can I get, friends? At first you 98 divided by 4. So whatever I get, 4 to the 8, 16. So remainder is my 2, and 2 remainder, when the remainder is 2, then 2 to the power 0 remainder, 2 to the power 1, then it is 2 to the power square is equal to 4. So 4 is my unit digit. Another problem is the unit digit of 3 factorial to the power 97. So friends, whatever you get 97 divided by 4, that is 24, and remainder is 1. We know that all factorial numbers starting with 5 factorial. So friends, whatever you get 3 factorial, that is 6. How you get 6? Because remainder portion is 3 factorial means 6. 6 to the power 1, that is 6. And similarly, when the unit digit of 4 factorial to the power 99 is also 6. How? Because 4 factorial means 24, last digit is 4, and another factor is 99 divided by 4 is equal to 24, that is 3. So 3 number means this is not 99, this is 96. So this is the remainder portion is 0. Remainder portion is 0. So 4 factorial is 48. Yeah, 3 factorial is 6. So 4 factorial is 24. Sorry, 4 factorial is 24. So 96 is divisible by 24. So that is 6. This portion is also 6. We know that the factorial number starting with 5 factorial has the unit digits. So friends, when 5 factorial has 5 present, so the unit digit of the unit digit of 5 factorial and whole to the power 95 is 0. Another proportion is also 0. So friends, because we know that 5 is present, 5 is present, so 5 is present and 2 is present, and 2 is present, so 0 is unit digit, so no need to calculate exceeds 5 factorial, because everywhere 5 present and 2 present, so unit digit is 0. So thus the required unit digit is 6 plus 6 12 plus 4 plus 1, that is 17. So last digit is 17, so 7 is unit digit. This is my answer. Now friends, again the question is number 3. Find the remainder 11 to the power 8 divided by 7. 11 into 11 into 11 into 11 into 11. How many times? 11 times. So total, I just write in here total 11 times. 11 times multiply. So it can be 11 times multiply 4 to 4 up to 4 divided by 7. So it is 11 times. So sorry, it is not 11 times, it is 8 times. This time is 8 times. This is 8 times. So whatever we get 16 into 16 into 16 into 16 divided by 7. So again we get remainder 2 into 2 into 2 into 2. So whatever we get just is equivalent. Okay, this is not equals to, this is equivalent, remainder portion, all are remainder. So remainder portion is I am getting this. So it is 16 by 7, that is remainder. Remainder is 2. So friends, now whatever you see that 1719, 1721, 1732, 1725, 1727. So 18, I have to be divisible by 18. So at first I shall divide individuals. So 18 divided by 1714. Then we get remainder portion is 9. So it is 9, it is 11, and it is again if remainder portion 9 into 11 into 13 into 15 into 17 divided by 18. So whatever we get total 117 into 255 divided by 18. 9 into 13 9 into 3 divided by 18 is equal to 27 divided by 18. This value is 3 divided by 2. So remainder portion is, because 9 cut, so it is 3 and it is 2, 3 by 2, and this portion is 1. When, friends, you must remember that a to the power n divided by a plus 1 always gives 1 remainder. This is also note remainder. Now friends, another question is, let X be a non-empty set and E and F be subsets of X. Define E del F and del E cross intersection F and E del F. So friends, let's start to discuss the problem. First is E del F del E So friends, another question is E intersections F. So this is called symmetry. Del notification is symmetry. What is the E del F? E del F means E by F, E minus F union F minus E. E minus F in union of F minus E. So friends, whatever we get E del F minus of E intersection F minus union E del F minus of E intersection F. Now friends, E del F. Now I will break this value. So whatever I get, E minus F union F minus E minus E intersection union and E intersection F union F minus E minus E intersection F. Now friends, E minus F, what is the meaning of E minus F and F minus E? This is the E and this is F. This is E. According to the Venn diagram, this is F. So this is the common portion. So this portion is called E minus F and this portion is called F minus E. So this is the union. Union portion is, this is mean that E union F minus E intersection F minus E intersection F union E intersections F. Because F minus E minus E intersection F. Here I have some mistake. I have there is some mistake. This is according to the definitions. This portion is E intersection F into E del F. This is my definitions. E intersection F divided by E del F, and in here E intersection F minus E by F union F by E. So friends, whatever we get E intersection F minus E union F minus E intersection F. So this value is E union F and E intersection F minus E intersection F minus of E intersection F, because E union F, because as A minus B equals to A minus B. So by the set theorem, okay, sorry, not A minus B, 1 minute, I will see. Let A equals to 1 to 3, so it is 1 to 3 minus 3 and minus 3. So whatever you get, friends, you get only 1 comma 2. So this value is equals to A minus B. So I can write E intersection F. Now friends, again, whatever you see that E minus F minus E minus F, E minus F minus E minus F equals to E union F minus E intersection F. So this value is E intersection F, this value, and E del E minus F union F minus E. And again, because the symmetry, this is the symmetry, so symmetry operations, so I just E minus F minus E, and again whatever I get same factor, that is E minus E union F and minus E intersections of F. It can be written this way. And another way is union of E F minus E minus E. And now E intersections F union F minus E intersections F equals to F. So now again I analysis how I can get this value. Now you can see, friends, E minus E in union F minus E intersection F. So friends, whatever you see, this is E and this is and this is if, and this portion is E intersection F. So whatever I get, I get this portion is E minus F, and this portion is F minus E. When we subtract from this portion E minus F and F minus E, this portion is subtract from E, then we get only E intersections F. E minus F union F minus E. So whatever I get only subtract positions, because this portion is different. So I get E intersections F. So this portion I get. So I hope I can clear. And similarly, you can get E union F and E intersection F minus E. So whatever you get E union F, E intersections F minus E. So whatever I get union, I get E union F, I get only total F. This portion I get because I subtract from E. This portion I subtract. So I get only F value. I get only F value. So F value I get, and F, and this portion I get just only this portion. So this portion is F minus, this portion is F minus E intersections F. This portion is F minus E intersections F, and now you will see that we added also E intersection F, so this value is F. I hope I can clear the questions answer. So my answer is in here F. Again, which of the following sequence and series functions are uniformly convergent on 0, 1? So friends, I have to find out which is uniformly convergent. Fn(x) n square x. So friends, in here f0 is equal to 0, f1 is equal to 0, and so and 0 comma x less than 1. This is the two interval. This value is 0 and 1, and fn plus 1 divided by fn equal to n plus 1 divided by n whole square into 1 minus x square, and this portion, this value is 1 minus x square as n tends to infinity, and fn x belongs to 0, 1, and mn equals to supremum of fn x minus fx, and x belongs to 0, and n square x into 1 minus x square whole to the power n equals to 0. So I mn test, mn equals to 0, and unx equals to n square x 1 minus x square whole to the power n. X divided by x is equal to 1 by root over 2n plus 1. As, how can I get? As f dash x is equal to 0, as f dash x is equal to 0, that implies x is equal to 1 by root over 2n plus 1. So mn equals to n square divided by 2n plus 1, 1 minus 2n plus 1 whole to the power n tends to infinity. So if mn tends to infinity, so it is not uniform convergence. So this portion is not uniform convergent, it is not UC. So this portion is not correct. Number C. Number C is mod of cos m to the power 6 x divided by m cube equals to less than equals to 1 by m cube. So as m tends to infinity, mn limit n tends to infinity, 1 by n cube tends to 0. So it is uniform convergent by mn test. So this portion is uniformly convergent. Another portion is number A. Number A is fnx cos pi n factorial x whole to the power 2n. Now x belongs to q, and where x is equal to p by q and p comma q equals to 1, then q factorial x belongs to capital N. Qx equals to p and cos m pi equals to 1 or minus 1. So minus 1 to the power 8 to the power 2n equals to 1. X belongs to q, so fnx tends to 1 and x belongs to 0, 1. Intersections of q, intersections of fnx tends to 1, and when x belongs to 0, 1, intersections of q, and when another case is when x belongs to qc, means complement of qc, then x does not equals to p by q. So in factorial x does not belongs to q. So whatever I get fnx tends to 0 when x belongs to 0, 1, intersections of qc. Fnx equals tends to 0, so fx equals to 0 as 0, 1 intersections of qc. So friends, I think that it is not uniform convergent. Number 1 is not uniform convergent because case arises in two case arises in here. This is not UC, so only not UC, only this portion is UC by the MN test. Next problem is very interesting, that is n cross n matrices A and B with real entries Next problem is which is the true, which of the following problem question is true. So friends, all the question is coming from NBHM, but I forget the year name. Okay, this question is coming, year name is NBHM PhD 2010. So whatever I get I minus AB minus BA. AB minus BA. So friends, A equals to N cross N. B into N cross N AB. So characteristic polynomial of CAB x equals to CBA x. That implies AB does not equals to BA have same set of eigenvalue, have same set of eigenvalue. So same set of eigenvalue, and I minus AB minus BA whole to the power n equals to 0. That means I minus AB minus BA is nilpotent matrix. As the nilpotent matrix, eigenvalue is 0. So eigenvalue is 0. So AB, this portion is plus BA, so AB tends to lambda. So BA tends to lambda. So minus AB plus BA equals to minus lambda plus lambda equals to 0. So I minus AB plus BA equals to 1, equals to I. So that is impossible. So so it is contradictions. This portion is, this is contradiction. This is contradiction. So it is not possible. This is contradiction. This is not possible. This is false, because we see that I minus AB plus BA equals to I. I means 1. 1 is eigenvalue. Eigenvalue is 1 because I is identity matrix. Identity matrix of eigenvalue is 1. So it is contradiction. So A is not correct. Again we will solve. So option A is wrong. Now we will see, if A is symmetric and positive definite n cross n matrices, trace of A whole to the power n greater than or equals to n to the power n det A. Now lambda 1, lambda 2, lambda 3 up to lambda n, and trace of A trace of A is equal to lambda 1 plus lambda 2 plus lambda 3 up to plus a lambda n trace of A, and date A equals to lambda 1 lambda 2 lambda n. Now friends, AM greater than equals to GM. So whatever I get lambda 1. So friends, this is the symmetry and positive definite matrices. Symmetry and positive definite matrices means lambda eigenvalue is positives and symmetry means real number. So lambda 1 and lambda 2 plus lambda n divided by n greater than equals to n into root over lambda 1 lambda 2 lambda n, and after that lambda 1 plus lambda 2 plus lambda n whole to the power n greater than equals to lambda 1 lambda 2 lambda n. So this value is the trace of A whole to the power n greater than equals to date A. This is true, and this portion is that 5 cross 5 skew symmetric matrix with real n entities, then A is singular or not. Skew symmetric matrix matrix eigenvalue is 0, otherwise purely imaginary. Skew symmetric matrix eigenvalue is purely imaginary. So friends, in here you get 5 cross 5 matrix. Must remember friends, 5 cross 5 matrix. If my eigenvalue is imaginary number, then we can get 2 or 4 imaginary eigenvalues, but one should be 0, so it is true. Must remember friends that imaginary eigenvalue is imaginary. So friends, imaginary, if it is imaginary, we can get another conjugate. Conjugate imaginary value. So 4 is possible. 4 imaginary eigenvalue is possible. Value is possible, but one should be 0, because complex eigenvalue is imaginary means complex number, then it has also conjugate term. Another problem is W1 is equal to P belongs to V, and P1 by 2 and P1 by 2. This is my total. So number of dimension equals to 21, at most 21, and W1 intersection W2. So friends, whatever we get W1 equals to W2. So number of restrictions. So friends, number of restriction P1 equals to 0, P half equals to 0, P5 equals to 0, P7 equals to 0, and P3 equals to 0, and P4 equals to 0. So 1, 2, 3, 4, 5, 6. So total is 6. So 21 minus 6 is equal to 15. So whatever I get 15 is my answer. Next problem is IIT KGP. Let M be the space of all 4x3 matrices with the finite field 3 elements. Then the number of matrices of rank 3 is in M. So number of matrices I have to find out. So how can I find out, friends? You have to must remember M equals to 4 cross 3. So rank of M is equal to mean of 4 comma 3, that is 3, less than equals to 3, and field is finite field F is equal to 3. Here F is 3. Here M equals to 4 and K equals to 3, means N equals to 3. So by the formula is that P to the power M B square P to the power M by P to the power N minus 1. So my answer should be P to the power 4 minus 1 and P to the power 4 minus P and P to the power 4 minus P square up to P to the power 4 minus P cube. This is my answer. Now we will solve another questions. This question is very interesting questions. That C0 is, next problem is very interesting. This problem is coming from IIT KGP, means IIT Kharagpur. That problem is C0 is equal to xn such that xn belongs to R, and for all that implies xn tends to 0. So dimension of C0 is equal to C0, and dimension of M is equal to C0 minus 1, and dimension of C0 by M equals to C0 minus C0 plus 1 is 1. So my answer is 1. Next problem is the matrix problem. So I have to find out base, then I can find out easily the problem. So my base is E1 2 plus 3 matrix. So E1 is 1 0 0 0 0, and E2 is 0 0 0 0, and E4 is equal to 0 0 0 1 0 0, and similarly E5 is equal to 0 0 0 0 1 0, and E6 is equal to 0 0 0 0 0 1. This is my total basis. So whatever I get TE1 equals to 0 E1 into 0 E2. It can be written this way: TE1 equals 0 E2 plus 0 E3 plus 0 E4 plus 0 E5 plus 0 E6. TE1 TE2 equals to, similarly it can be written this way, because TE1 equals to, it can be written TE1 is 0 0 1 0 0 1 and 0 0. That's why I can write this way, and TE2 can be written, this is my TE2 value, 0 0 0 0 0 1. So it can be written same this way. This is the last, this is way it can be written TE2 TE3. So TE3 also same way. So whatever I can write this way: 0 0 E1 0 E2 0 E3 plus 0 E5 and 0, not 0, it is E6. This way I can write. And TE3 I can write, TE3 value is 0 0 0 0 0 0 0 0 1. So sorry, not 0 0 1, this is 1 0 0. So it can be written 0 E2 So similarly I can get, so friends, this is the column vector of the matrix. This portion is column vector of the matrix. So friends, I will not work so much because this is very simple. So you can easily, I can guess this is the matrix should be this way. My matrix is, T matrix is 0 0 0 0 0 0 1, sorry, 0 0 1 0 0 0, and another is 0 0 0 0 0 1. Another matrix is 0 0 0 1 double 0. 0 0 0. Another is 0 0 1 0 0 0. One minus 1 0 0 0 0 0. Because minus 1, how can I get? Minus 1 I can get because minus x6. Minus x6. So t e6 is equal to starting point will come minus 1 into e1. Okay, after that 0 e2 0 e3, this is the coming. That's why the value is minus 1 and is coming. So if we rearrangement, so t can be written this way: 1 1 1 1 1 as diagonal form. Another is 1. This way we can get the value. And determinant of t, whatever I get t, determinant of t is minus 1. Very simple, friends, not tough. Determinant of t is equal to minus 1. This is my answer. Another problem is Q symmetric orthogonal real matrix is plus minus 1 plus minus I plus minus 1 plus minus 1 plus minus I. 4 cross 4 4 cross 4 matrix. So friends, how can I solve this problem? Problem is very simple. Problem is 4 cross 4 skew symmetric matrix. Skew symmetric matrix eigenvalue of skew symmetric matrix must remember this is 0 0 and imaginary number. An orthogonal matrix, for orthogonal is date A is equal to 1 as orthogonal matrix. So no chance to be 0. So no chance eigenvector is 0. Eigenvalue is 0. So only imaginary number is possible. So in the given question, number D is also correct. Wrong. C is wrong because plus minus 1 is also real values, and real value is plus minus 1. This is also wrong. Only option A is correct. Another problem is find 2-digit number having different digits which is divisible by 5. So friends, I already choose 2 number. There is 0 and 5 should be. One possible is 0 and 5, then it is divisible by 5. So when it is 0 divisible by 5, then the possible entity should be in here. Number should be 9. Number can be replaced. So 9 way. Case 1, it is 9. Case 2, when it is 5, in case of it is 5, then the possible way is, so it is 0 and 5 will not in here. So it in here 0 and 5 is not possible. So only 8 number can be seated. So case 1, case 2, we can get only 8 numbers. So total is 17 way. So answer is 17. And second is Very simple. 7 is second possible is Euler total functions, 5 functions. So I can get phi 10. If I get phi 10, so phi 10 value is phi into 2 into 5. So it can be written phi 2 into phi 5, and it value is 2 into 1 minus 1 by 2 into 5 into 1 minus 1 by 5. So this value is 4. So this answer is 4. Thanks for watching, friends.